Welcome to 3D Native's webinar, Optimizing Distributed Supply Chains Through Metal Additive Manufacturing. My name is Madeline Pryor, and I will be the moderator today. I am joined by our panelists, William Priest and Ricardo Tosi, both from Velo3D. Good afternoon to you both.
Hi, Madeline.
Hello, good afternoon, everyone.
So I will introduce myself and the panelists in a little bit, but while people are still trickling in, I actually just wanted to have a couple of housekeeping things to let you know. There will be a Q&A session for the last 15 minutes or so of the webinar. So do make sure that you ask your questions at the bottom of the screen. There's a Q&A section. If you ask them there, it just makes sure that we see them, whereas things do get lost in the chat. Additionally, the webinar is being recorded and the replay will be available later on our YouTube channel. If you'd like to be notified once it's online, you can subscribe. We have a lot of other exciting 3D printing content, and let's get into it. So on this slide, you can see the agenda for the next hour or so broadly. After this introduction, where I will give you a little bit more context for the current state of supply chain crises, we're going to go a little bit more in depth about Velo3D, as well as how its metal AM solution can be used to address these disruptions. Then our panelists will discuss some case studies with parts that were used by companies to solve different issues with their supply chains. And as I previously mentioned, the final 15 minutes will be a Q&A. Don't forget to ask your questions in the bottom. And moving on, well, as I mentioned, my name is Madeline Pryor. I am the English content specialist for 3D Natives, the largest international online media platform on 3D printing. It is available in 5 languages, English, of course, but also French, German, Spanish, and Italian. I am the moderator of this panel as well as the Q&A. And now to our very exciting panelists. First up, we have William Priest, who is the sales director of the UK and Nordics at Velo3D, where he is responsible for shaping and executing the sales strategy in this region. He has a degree in mechanical engineering from the University of Exeter and actually began his career as a design engineer with Red Bull Racing. He then joined Dyson's EV program as an advanced design engineer before moving to a product design, development, and production company, exploiting thermal management and lightweighting via AM before moving to his current role at Velo3D. Next, Ricardo has over 2 decades of experience in manufacturing with a diverse background in additive manufacturing, actually 10+ years, production, research and development, and CNC machining. He worked as a senior research engineer with directed energy deposition technologies at the Manufacturing Technology Center for several years while he earned his engineering doctorate in metallurgy with electron beam powdered med fusion from the University of Birmingham. Before moving to Velo3D, he had a research role at the Singapore Center for 3D Printing and worked as an application team lead for another leading provider of metal AM solutions. And as I said, they both work at Velo3D. For those of you who don't know, for whatever reason, Velo3D, they provide a fully integrated metal 3D printing solution for mission critical parts in the space, automotive, semiconductor, and energy industries, with even more coming, I'm sure. So moving on, let's talk a little bit about supply chain disruptions. So since 2019 and the start of the COVID-19 pandemic, supply chain disruptions have been rife worldwide. Wow. And though they have decreased since their peak in 2020, they have once again started to steadily increase, as you can see in the graph with data from the International Monetary Fund just to the right of the screen. This is due to a number of factors. This includes, of course, the fact that we are actually still feeling the long-term effects of the COVID-19 lockdowns, but also there are current labor and material shortages, including a global chip shortage and a plastic shortage, which has been affecting sectors for a variety, but especially healthcare, and current geopolitical tensions, which are redefining trade routes in a lot of countries, as well as restricting access to critical resources. This is notably in the oil and gas industry, of course, among others. But where exactly does 3D printing come into this? So moving on to the next slide, if you look at this image from the US Census Bureau, you'll see that most supply chain disruptions are actually happening in the manufacturing sector. And to add on to that, manufacturing is also one of the sectors with the most outsourcing, which, as you probably know, could be a contributing factor to those disruptions as you're relying on even more parties. by integrating something like metal 3D printing technologies, as we'll discuss in this presentation, this could be reduced, helping to localize production and decreasing the need to rely on other companies who might themselves be impacted by various shortages or other issues. And it's actually for that reason that 3D printing, as you can see, is becoming one of the key technologies in the supply chain industry overall, again, seen in the image on the right. And that was actually enough from me, and I'll be putting you in the capable hands of our experts. Once again, the reminder, do not forget you can ask questions at any point in the Q&A at the bottom of the screen. Please do ask them there. It makes them more likely that we will see them. Additionally, we're going to be sending some polls, including 2 right now. I invite you they will pop on your screen in a moment. I invite you just to answer them. It just helps us get a better idea of who our audience are and getting some more information about you and engagement as well. And well, I'll let you take it away, Will.
Thanks, Madeline. Welcome, everyone. Thanks for taking the time this afternoon, and I hope you enjoyed the discussion. And yeah, I'm very keen for it to be a discussion. So at the end of the webinar, please bring your questions around the topic. I believe some of the poll questions are up at the moment. So as those are being finalized, we'll begin. So Madeline touched on it before we started, but it's good to understand, especially as an OEM in the market, what are the current challenges of some of these supply chains. And this really is cross-sector. So whether you're in aerospace, space, oil and gas, there's some common themes here, but there's also some quite unique themes for some of the sectors out there. The first one really that we're seeing is legacy manufacturing techniques such as castings are becoming very expensive and even monopolized in some particular regions and some particular sectors, as well as forgings have ever increasing lead times. And that's down to a number of factors, but really it culminates in some of these legacy techniques are now being questioned about their technical and commercial feasibility. We see a reliance on tooling. For specific industries, there is a reliance on tooling, and ultimately that can drive development and production times a lot of the time by the ultimate tooling lead time. Another big challenge, especially in certain particular markets such as space, is that some of these legacy supply chains cannot support the fast accelerating, fast failure markets. It's quick innovation. It's very much build, test in the low TRLs to get to the higher TRLs. So, when we look at additive, we'll have a look a little bit at how we can support these fast moving developments. As well, it's not always the case, but some of the conventional metal additive supply chains don't always have robust and repeatable solutions. So metal additive is a very common word within everyone probably in this room, and it at one end can be a very marketing heavy term, and on the other end can be a very industrialized term. And really it's, when we look at the different range of what's out there in terms of printers, it's about understanding what is for the need, what is for prototyping, and what is for a more industrialized process. Something which is very interesting, which additive as a whole brings, is OEM systems rely a lot of the time on multi-source components assembled together. If you can ultimately reduce this assembly and consolidate into one part, you can also consolidate your supply chain at the same time. So essentially, you would only have to buy from one supplier under one roof, which makes things a lot easier. And it's a lot of the time, the customer conversations do start with this. And we've got some interesting examples a little bit later around how we leverage that. So there's a couple of themes to think about as we move through the webinar. Very keen to be challenged on these later as well, and have a discussion around some of these. Okay. So before we go into the detail, just a little bit around us. Velo3D, born out of the US about 8 years ago. We went public at the end of last year, And part of why myself and Ricky are here is expanding the knowledge base and our customer base into Europe. It is a metal AM solution, additive solution, and it's all around the focus around delivering complex, high-value metal parts without design or quality compromise. As we say, we're a global company. On one side, we support customers directly, and on the other side, we have a large CM network to support our customers. In terms of who we serve and some of the interesting ones in terms of supply chain, sort of the first example of this is a company called Launcher, one of our space companies, who ultimately had a really quick necessity for lead time, essentially. So they had a very fast make development process where they needed some large Ti 6.4 tanks. And really the whole reason why they were utilizing additive in that sense was to reduce that initial lead time, along with some of the inherent technical capabilities that we can offer as well, that you would not be able to do with legacy techniques. So some of our support-free technology. Something as well within the energy market, we're seeing that, you know, the focus on castings and legacy castings within the energy industry are being monopolized. So big players in the energy industry are looking elsewhere for alternative manufacturing techniques to reduce that lead time and ultimately dual source their supply chain, which is a very interesting conversation. In terms of what we do and some of the examples where we really have integrated into legacy supply chains are around parts which are optimized for controlled flow and the transfer of heat. So everything on the very high end, large parts such as this Inconel 718 impeller, which is a typical oil and gas or energy part you might see made by a legacy casting operation. This can now be made with additive, with no tooling cost, with no upfront, minimum order quantity. You can make 1 off, 10 off, 100 off, as and where is needed. So not only are you reducing your lead time, reducing your tooling cost, but with the solution, you can almost have a just-in-time manufacturing operation close to the site of where you might use this. So typically some of the oil and gas OEMs will want to build close to their oil and gas pipeline, let's say. We can talk a little bit later about some of these case studies, and I believe Ricardo will be going into a specific oil and gas case study. The interesting thing about supply chains is that, especially legacy supply chains, things are essentially qualified, industrialized, standardized, and this is the way it's been done for a large number of years. And this is something which is a hurdle to overcome as we open up new additive supply chains. On one side, you have an industry level standardization, so things like NACE, MMPDS, which you need to understand and you need to qualify. And then on the other side is a manufacturer level standardization. So something that we offer as Velo3D is this manufacturer level standardization. And really it's about understanding as a supply chain what you need to enter these supply chains. So it's about part quality, part qualification, and making sure we can deliver the right standards to these bodies. As we focus on a fleet level standardization, so more of a global presence, it's around reducing the barrier for people to essentially qualify parts and open up that new supply chain. On one end, you very much have an open source platform. Some OEMs use this, essentially giving the end supplier or the end user the right to change parameters to their needs. And on one end, you have essentially a lockdown system. Velo3D ultimately sits in the middle to allow flexibility for design. And what this allows you to do is essentially assign parameters at the front end of your additive, reducing that initial lead time and initial design time. All of this allows for a flexible supply chain for either in-house or what we call contract manufacturer source manufacturing. The outcome is ultimately a standardized and validated material property set at the fleet level, which can be used to support your distribution of parts and supply. We touch a little bit on it, but what I will just go through before Ricky goes through the various case studies is about what we do and how we integrate into supply chains. Ultimately, we sit in the supply chain as a process and a technology company. So we offer the hardware and the front end flow software and the Assure software. And what the focus here really is about the standardization, design freedom, repeatability, and quality to ensure that we can compete against some of these robust supply chains and ultimately produce a global footprint that customers can produce parts on. And we'll go into a little bit about this later. As I say, on the front end is the print preparation software. And what this ultimately does is produces what we call a golden print file. So for me, robust supply chain starts here at the data level. And this is what we're offering at the front end, is effectively locking down the part for ultimate qualification as we move through the process before we deliver to the customer. So really, for me, robust supply chain always starts here at the data level. It then goes on to the hardware level, and many of you might have already seen our family of printers. And what is very interesting about this, I won't go into too much detail, but hardware that we've developed has been driven directly by the voice of the customer requirements from supply chain issues. So essentially, where customers are needed a very flexible supply chain, customers are needed specific geometries and specific validation of parameters, this is where we've developed our technology around, and we will continue on that roadmap. As well, something which a barrier to entry on many a new supply chain is the quality assurance of a part and the validation of a part. And essentially what we've done is ensure that we can meet that standard or even produce a result which allows us to get over that barrier for validation. So effectively in-process monitoring, automatic build reporting, automatic calibration, something that against legacy systems you might see is even better for qualification, and ultimately gives the user who's trying to build a global supply chain that confidence moving forward. And what this culminates in is essentially a single source, standardized, robust supply chain options for OEMs. Ricky will talk about it a little bit later around the golden print file, but essentially what this allows you to do is negate some of these challenges of supply chain. So essentially, you don't have to rely on legacy manufacturing techniques. You can ultimately dual source globally. There's no reliance on tooling, legacy supply chains, which have long lead times. You can almost get rid of a lot of those, take those 50 weeks or 20 weeks down to a couple of weeks. So really, this is the benefit of the validated system. That's all from me. I'm happy to take some questions at the end around any specifics around this, but I will hand over to Ricardo now.
Thank you, Will, and to Madeline for the introduction. So after getting through the main topic, I would like to dig a little bit more in more details, like the challenges that we currently have in the supply chain to qualify components and how the market is currently addressing these issues. So Will is driving the slides, so thank you, Will. I will shout to you when is needed. Thanks. So getting back to the topic, we have several challenges these days on the supply chain, a global supply chain, and how to qualify parts and how to address the manufacturing with additive manufacturing. So as Velo3D, we are working on several manufacturers these days on several contract manufacturers as well, like end users, and also who's making parts, just to understand how we can improve the global supply chain and how we can manufacture parts through additive manufacturing. But it's not just how to manufacture the part, how we can make them consistent, how we can certify the part, how we can get the right certification, that we can address the part, the right level of quality and all the process chain. So today we have, we're covering an example of a valve, is a drag valve especially. I don't know if you're experienced in valves, this is definitely a special one. So we can see the this cylinder, which is like a plunge valve in the middle, which is moving up and down. There's a flow getting through. Is a flow which can be like a liquid or gas. It depends on the application. It covers in different fields, like a fossil, nuclear, oil and gas. So moving this plunge up and down, you can get the. Can we go back to the previous slide, Will? Thank you. So if you move up and down the plunge to the stage, you can control the pressure. Depending on the pressure is going through, you can move it up and down to control the valve. And this flow is going through these intricate holes. So these intricate holes are controlling the flow, and conventionally in normal valves, they can generate a lot of noise. They can get a lot of vibration, and it's not very much sustainable for the business in terms of like replacing the valve itself and for the operators that are around the valves. So if we can go to the next slide, we see that this valve is conventionally made with discs assembled together, and then there are some holes, some different geometries that can be places just to make like a pattern for these discs. When they get assembled and stuck together, they get brazed conventionally. So it's kind of like a long process to make these valves. But on top of this, we can say that every valve is different geometry depending on the application, so they can be very much customized. So most of the time we don't see the same valve, so there is a request of different design. So here the matter is having like a quick response to the customer and the design that they have, and that this can be called as a big manufacturing of parts because we have like different design, different requests. So it's very difficult to stay behind the request of the customer. So using like if we go to the next slide, we see that an example here of the old design that is in the back of the picture, that are like this stuck together, and the new design explore via additive manufacturing. So there are several advantages here, because you can make like a monolithic part in one go. You can really refine your channels in the way that you are willing to use the valve itself. And on top, you can really optimize all the shape of the holes. So is very new approach, and this can be done in one single step, and optimizing also the weights and the design. So if we go to the next slides, we can understand in the way back that they're trying to manufacture, and especially to address the challenges to make this complex part in additive manufacturing. So as we are all of us aware, there are some certification that need to be addressed to make the part usable during the manufacturing. So there are some standards that can be driven in different fields. So we can, for example, see aerospace. Aerospace has like the same material, or almost the same material used in the past few decades. So it's very challenging to bring like new application and new manufacturing strategies to the field. So what can you really do to address new metals, new parts in the supply chain using additive manufacturing? So there are a lot of challenges. So what we done, we can see in the next slide, what we try to do with the IMI CCI to address these challenges. So we follow like a path to try to develop this new valve using additive manufacturing, but not just making itself, try to address and certify the component just to get it allowed to be mounted, to be in service and working. So if we go to the next slide, we see some fundamental steps that we follow during the qualification of the parts. So there is a full integrated chain that need to be addressed. And it's quite complicated because it's not just the part, it's not just the end user, it's all of them together, including the qualification that you need to address to get the part able and suitable to be placed in the field. So if we go to the first step, next slide, so we can see that there are, this case is oil and gas, where the part is going to get located. So there are a few certification like the NACE, which is about corrosions. So there are some standards that have been placed in the past. Not all of them address additive manufacturing. So we still have a lot of gaps here in both oil and gas and in other fields. So what we've done in order to succeed on certifying those components. So we did a lot of tests, mechanical tests, lots of prints, a lot of post processes that allow us to prove the quality of our component itself. So if we see the next slide, we can also notice that there's a various number of tests that we've done on our builds just to get the first data to really prove that the part itself can be good enough to be certified, like from mechanical, from the test that happened before, the characterization that happened afterwards. So a lot of steps, complex steps that are introduced to really better understand what we are going to print during the manufacture of the part. So if we go to the next slide, we can notice that after we get all the standards together to certify the quality of the material itself and to get aligned with the standards available in that field, we can then demonstrate how the system can be reliable. So in our case, we do have a report that is being generated from our system by our software called Assure that can really address what happened during the builds. And afterwards, this report is being plotted on the graph. And then also the valves that have been manufactured with our system have been plotted. So we can see the trends. Basically, this test has been done with the flow, with different pressure and flow. And the data are really kind of matching together. So we've seen like a good consistency generated. So this test was focused on and trying to address some standards. This is more like on a AP20S that has been done in oil and gas, but there are all other standards in other fields that can be used to certify components. So after we check the system itself, there is the part qualification. So the part qualification is the last stage that they need to be done by all parties. So by the machine itself, so how the machine can be reliable during the time, it can print the same part, and how the part can be qualified itself. So our system are all they all do a pre-setting, a pre-alignment of the machine, a pre-calibration that can guarantee that all the systems are calibrated at the same level all the time. And then the report is showing all the results of the part. So this gives you like a preliminary report on the quality of the part, and afterwards there is the qualification of the part itself that it can be done in the field. So the combination of the pre-qualification of the machine, pre-qualification and calibration, the manufacture of the part with the report that show you if there are like issues printed on the part, and the quality of the part itself, and the test of the part that we can see in the next picture. So we can see here that we actually perform like live test of the components. So the component is being mounted on a rig. It's been done like a load test here, so we can actually see like a proper test has been done. So all of these data all together, pulled together, they can really certify your component for a distribution of parts in your manufacturing chain. So it's very complicated to address all these items. So there is a big procedure to follow. So actually this test was like kind of successful. So this part is actually being mounted in Wales with good results. We notice like an improvement in corrosion. So it's actually real parts that have been manufactured. As we're working with them, we're working with some others on try to get around all the standards to certify parts for us to improve our global supply chain, and really give another option on how we can manufacture parts globally and even localized, just to get a more flexibility in manufacturing and the supply chain. So saying this, the settings and the golden file that is being generated in our system allow us to guarantee the execution, the printing of the same part, wherever you are globally, because all the settings, all the files in the machine will be the same. So no matter where you print, if you print in the US, if you print in Italy, in the UK, in France, so the system, the outcome should be the same one. So we did some tests in the past that certify this as well, and with the excellent results. So if we see the next slide, as I'm saying, with one part, we can really explore several parts to get to the next level on how we can really certify parts globally together with the end user. I know it's very challenging. I know there are a lot of steps to do certification that are still missing sometime, and some demanding end customers that would like to have a very high quality part. So we're working together with several companies these days to allow this improvement in the supply chain. So saying this, I would like to highlight some benefits that you can get from the systems that can operate with our internal recipes. So you don't need like very high experts running the systems. So we have a full key package with the flow print to prepare all the file and print the part by itself, and the software flow that can generate the pre-checks and the report of the part itself, just to certify and validate your prints. So this is a big advantage, I would say, in terms of like manufacturing parts, get standard components, and generate like a production chain of parts that can guarantee the same quality every time. So the next slide will say like how IMI CCI generated like a good benefit on those parts, because they can really scale up the supply chain in a global way. They have a quick response on the manufacture of parts because you don't need to have like a stock of components. So you can really make your ad hoc disk whenever you need it in the facility that you really want, more localized. So an improvement in design, this for sure. And you can even make disk stacks up to 600 millimeter in diameter, which is something really, really big these days. So closing up, I would like to thank you very much for listening. And I will be presenting again in Formnext. So we'll be in Formnext, so you can come to see us. It would be very nice to hear your question, your feelings about supply chain, but especially the challenges that we all have these days on supply chain and standard available in the market and how to address those issues. You can see also other exhibitions on top. So we are waiting you for some feedbacks and see you very soon. And I'm happy to answer your questions.
Well, that is my take. Well done, gentlemen. You were quite efficient, but actually a little bit early, but that's fine. Once again, guys, do not hesitate. We have a few questions already. You can ask them in the Q&A section at the bottom. I saw someone had raised their hand. Do feel free to just ask the question and we will answer it. You can also upvote the questions that you would like answered so we can see which are the most popular. If you would particularly like a question answer, I do recommend you do that. But well, we can start with a question from Len Pannett, actually, who comments that a poll on what is holding us back missed one vital and constant element, IP. How do we overcome questions of IP, particularly for spare parts and other items? If you have any thoughts.
Len, this is a very good question. So I can give you some real examples. We can stay in oil and gas here. So we are working with several manufacturers these days that they supply parts to end users, and they have like a lot of challenges on making parts in additive manufacturing and guarantee their IP that is not like broken or taken by others. So is a really way how you can deal with your end user and how the machine manufacturing can support you making your parts, but it's like it's a table conversation that they need to address with all parties. It's very complicated, it's very tricky. So you probably your IP is a number of items altogether. So it depends how strong you get the relation with your partners and how you can really hold back your IP and how flexible are you on sharing a few geometries that are not like totally related to your IP, but they can help to solve the issue and get your part manufacturing in additive manufacturing. So it's very tricky, to be honest. So if you have more questions and you are in Formnext, please come to see me because it's really related to the geometry of the part itself, if it's an assembly or if there's a single component.
Indeed, definitely go see them and if you have more questions, but also feel free to keep asking the questions as well in the Q&A section. We have a few that are coming in. The next one is actually from Herb Bennett. He actually has two questions, but I'll just do the first one right now, which is what progress is being made with shrinkage, RE different metals, if you know.
Ricardo, yeah, I'll take the other two.
Okay, so shrinkage, I'm not completely sure about shrinkage. I know we have distortion, I know we have tolerances that need to be respected. In terms of shrinkage, I'm not sure if you are also referred to post-it treatments on tolerances that you can achieve during the print. So I'm not completely sure which is the main question here. If you would like to write it like in more details, I can try to help you out, because metal, the shrinkage is normally like wherever you fuse, whatever you get normally, more or less. In terms of like shrinkage, we don't have any green here, so or brown. So if you would like to be a little bit more specific, or you have a case that you would like to highlight, I would be happy to support.
Great. Well, yeah, feel free if you're to ask it again and you can add on comments, or you can add on another question. I'm going to try and get it to as many as I can. I'm going through now with the most popular, just so you know. So if there's something you want added, please do upvote it, and that way I will see it. Well, it's another one from Herb, actually, which is, as an industrial designer, a test for watch designer printing a workable mechanical timepiece is the 3D holy grail. How far away are we from this precision, tolerance, and accuracy with metals? Thank you.
Right. So good question. I mean, I remember my old days when I was working with several technologies that we have like a lot of high precision tools that we need to select to make precision engineering cuts or design or laser angles or laser patterns to make interesting features for watches. So the tolerances is normally related to your powder size, your laser spot, and your Z high in terms of like layer thickness. So you will always have, and also depending on the size of the part that you print, if it's like very minimal or very big, more big it is, more the tolerance it can vary. So I would say if the part is small, is below a millimeter, if you 0.3, 0.2, really depends on the geometry itself. So it's very difficult to answer this question. I would say that our system are really big and we are more focused on big components, not like a watch, but I'm sure you can really get into interesting design. More than tolerance is more like intricate piece of design. I don't know if I directly answer your question, but I got slightly around it because it really, again, depends on what you're looking for.
Indeed. And actually just Herb had a clarification point, which is, I think this is for the previous question, which is that it needs to be a one-step pass holistic process, if that helps you any. Otherwise, I can also move on to some of the other questions.
We'll cover off after, if that's okay. We do have some detail around shrinkage, I think we could probably share with her.
Perfect. Well, then I'm going to move to the next question I see, which is from Stefan Abed, who wants to ask, if your process is 100% under control, does the customer still need to control the final part or tensile test specimen around the part?
This is, this is an interesting question. When Ricardo was talking about qualification, he started talking about material qualification and then the machine and then the part. I think you always have to, they're not explicit, you know, they're not you know, one after another, they're essentially concurrent. So we still use the technique of tensile bars, powder samples on the plate, as many others do, to verify that we are meeting material specs. It's an interesting question. One day, will we not need to do that? That we'll have the data sets built up. I think it's probably a question around how many data sets are in the industry, and things like working with MPDS and NACE can only help with things like that, really, from my point of view. One for Ricardo as well, maybe, if you want to.
Ideally, when you start to do your production, as all production, you start to test randomly your parts, maybe before you're gonna start like more often your components. But more you go on, the more you build your confidence in the way you manufacture the part, you will need less and less tests to be done on your components. So it's like conventional manufacturing. When you get confident on your methodology, and is proven and certified, you find the right approach on it. It should be like straightforward, I would say.
Yeah, from my point of view as well, from the automotive industry, when you're building thousands of cars, hundreds of thousands a day, normally you check one in every 100 or one in every 1,000. And if you find an anomaly around that data set, then you go like 10 either side. And if you find anomalies again, you go 100 either side, 1,000. So as the industry grows, I think, and as we see bigger volumes, I think, it might follow legacy manufacturing techniques around that. But for now, everyone wants to know exactly what's going on.
Which is valid. And actually, just because it's kind of following a similar vein, I'm going to ask another question, which is, well, which standards should you follow when you have calibration across companies, countries, or with many companies produce part or a component?
So in terms of calibration, if you're talking about the additive manufacturing system calibration, we can say that Velo 3D system, they have auto calibrations. So they calibrate everything they need to be calibrating inside a plus and minus. There's a minimum and maximum range. So you will always stay inside the range, which can guarantee you the calibration of the system itself. So this is what we were saying, no matter where your system is, you're gonna have always the same calibration, like plus and minus inside this spec. So in terms of like standards, again, so if this is in regards to the component itself, so you need to dig which is the standard reference for your part to be manufactured in additive manufacturing. If first there are standards available in additive manufacturing, and then if you can follow them to manufacture a part, and then you address them with the system, and then you can try to take all your questions and answer them. So if you can match the standards, if you can manufacture the parts, and then see if the qualification is possible. So it's kind of like a procedure that you need to have. So I hope I answered the question.
No, I think that does. Great. And actually, well, we have a couple more. So just very out of left field, but it just got enough votes, so why not? Which of the sectors do you think would most benefit from adopting metal 3D printing in order to overcome supply chain disruptions, in your opinion?
You go first, Ricardo, and then.
Well, it's always the equation like cost and number. So you always need to justify what you make. So there is always like a case study behind it. So you need to understand what you would like to manufacture and the impact it's going to have on the supply chain, which is related to your main to your drivers, which can be like cost, weight, time. So, and then you do all your equation. You put together all your equation and see where you can get the benefits out of it. So we would say that it can definitely, it would be easier to start with fields where there are not people on board, I would say, where the certification is slightly easier. So like new space, oil and gas is definitely a good field to start with, or even prototypes where there are no people in, like but even small number of parts. So this is what I'm seeing. Will, have you got any
Yeah, I think to add to that, something we've been seeing very specifically and probably within the last 12 months as the world becomes a very different place is any sector which is relying on castings. So that could essentially be from an impeller, a large impeller in oil and gas or energy, all the way through to hot or cold engine components on an aerospace platform. And really a lot of the challenges there are around size, and as I say, the monopolization of casting globally, and only a couple of casting houses being able to do this size. So that's where you'll see a lot of companies having bigger and taller printer beds, let's say. So I think that one's really interesting. Anyone who utilizes castings. Yeah, and then anyone really who's trying to develop quick. I think there's a fine line between like fast development and prototyping, and it's all relative to the industry. A serial production in motorsport might only be 10, whereas serial production in aerospace might be 1,000. So You've got to take it by case basis. But anyone really who's developing fast and needs components globally fast as well. So I'd say the space guys and more commonly the aerospace guys as well.
Yeah, that would make sense. And so we did that. And the next one is again different, but I think it will be more straightforward to answer as well. What is the highest definition in microns that is achievable by you today?
Well, we would say that we are pretty standard in terms of powder size. So the powder always most of the time drives tolerances. So depending on the material, we are around 10 to 53 microns. So standard powder bed, laser powder bed fusion.
Great.
And I guess the impact on the part there, Ricardo, is again dependent on the material, but
right.
Anything from thin walls to bulk material as well. And I think classifying, a thin wall vertical to at an angle to a horizontal, there's probably 3 different figures we could give you around the definition of the thickness. So yeah, happy to answer that one offline.
That's correct.
Yes, feel free. There is an email address that is on screen. You can contact OSO. They will both be at Formnext, I believe.
Yeah, with some wonderful parts as well. Big, small, yeah, all kinds of things.
There you have it. If you're going to Formnext, definitely stop by Velo 3D. And we just have a few more questions. Let's see how many we can get to. One is, can legal issues, for example, patents and standards, ever interfere with the solving of supply chain issues?
Good, very good question. Yeah, this is an interesting one. I think the world again has changed a little bit, and maybe 2 to 5 years ago, a lot of people, patent standards would stop progress. But I think now people are starting to question those standards. Patents a little bit harder, but definitely in terms of standards. I mean, many of the additive OEMs and customers are working with the standards bodies to rewrite old standards or even put additions in for additive, which I think is really interesting. So, there's a new qualification of those standards. I think it's driven by a necessity for change, really, and a need for development, whether that's, because of supply chain issues or environmental issues or drive to net zero. People are having to look at things a little bit differently.
That's
that's
definitely a good answer. I feel that's depending on the effort that the people would like to put in, because you can find a way to certify parts despite the challenges that you have in current standards and patents that they are pending. So it's really the matter how strong is the change that you need to have, how the twist you need to give to this production, to the component itself, and the energy that you need to get into the certification path. So it definitely can be an issue indeed.
I think a great example of that, it's a US example, but the privatization of space travel and people launching when essentially it was only government organizations and the NASA's, and now you've got many US companies doing it, and now in Europe as well. So things have changed really, and it's a new breed, I think, in the last 5 years for additive.
That's true. I think a lot of things came into play as well, especially after we started seeing the supply chain breakdowns. There was a lot that changed. Another question, which is, do you use simulation to test configurations and eliminate unfeasible ones and identify the optimal one regarding the targeted criteria?
This is really driven by the customer, really. So if they really feel that there is a case study needed for the parts, we can really do some optimization. Sometimes we call it design win. Sometimes you need to identify really design that it can be a potential design win, but the design win doesn't need to be the part that you're currently make, or can be, if you're lucky, the part that you're currently make, but can be like revisited slightly to be made, to be optimized, to be improved using additive manufacturing processes. So the answer is yes. It really depends on the part and the potential of the parts to be like a potential design win candidate.
Okay, well, we just have a couple more questions. I think we can get them out, unless feel free if you have any other questions to ask them or to contact the email, or again, find them at Formnext. I'm sure they will be happy to show you and answer anything you have. But first is, well, a controversial one maybe to end. Is metal additive manufacturing better than polymers for helping companies who are looking to address supply chain issues? What do you think are the benefits of metal AM over polymer in this case?
I would give a fairly, probably a rubbish answer, but essentially it's all what tool in the toolbox that you need to use at the time. Polymers are great at prototyping and in serial production, as are metals, but ultimately it depends on your part or system function. So whether there's a inherent need for thermal performance or structural performance is where you use either. I think maybe polymers are maybe a little bit more accessible than metals, but on the lower end, I think metals are becoming way more accessible. But I think it all essentially kicked off with polymers. So for me, it's a simple answer: is what's the tool in the toolbox that you need to use.
Sure. And then the last question, I'm not entirely sure I'll understand, but that's okay, which is how global are the supply chains for metal AM? Are they generalized, more localized, or global?
This is a really good question for me, because there's many machine OEMs out there, and you might have a machine X in the US and machine X in Europe or the UK, and it's the same machine. And you can talk at that level around a supply chain, but these machines might be in different contract manufacturers owned by different people. So is it a robust supply chain? Probably not. And that's something we are focusing on, really, is essentially building our own supply chain with the contract manufacturing network. I'd say, you know, on either level, they are global because the machines are there, but whether it's robust globally, I'm not entirely sure.
Well, we can definitely add that it is a great time for metal AM. Is growing, the technology is getting more mature, the customer are getting more ready to spend more time investigating if is a good approach to be used, either buying a system or getting parts made by 3D printers. So I think things are moving. Industry 4.0, so this is for a reason. So this is one of the way of the future, this for sure. And it can be better for sure, and in the next years and decades will get better. That is guaranteed. Well,
what a wonderful way to end a webinar. Well, in that case, we have actually answered all our questions. So with that, I think I will say, well, thank you everyone for attending. Again, if you want to watch this or share it later on, it will be uploaded to our YouTube. And especially a huge thank you to you, Ricardo, and you, Will, for coming and for your expertise. It was wonderful having you for the webinar. And
thanks for having us.
Thank you for inviting and for hosting.
And with that, I will say, well, have a great evening, afternoon, morning, depending on where you are in the world. And well, hope to see you in the next webinar. And don't forget to check out Velo3D.
Thank you.
Thank you.
Don't hesitate to reach out. See you later.
Bye.
Bye.